Hello students. Today we are wrapping up our final lesson for volume, and really no new concepts. Um, we are dealing with what we call composite shapes, and composite means it's just like different shapes that add up to make another shape. And so we're just going to combine what we know from cylinder, cone, and sphere to solve new shapes for today. Okay, so that's our goal today. We're basically just going to add or subtract what we already know from those three shapes to create new shapes. So our EQ is what are composite shapes and how do you solve the volume for composite shapes? Okay, so for this example, we have a cylinder with a cone that has the same radius right on top of it. Okay, so we're going to find the volume of these of this shape, and the shape is just two different shapes combined into one. So again, there's not much that is tricky about this one. So if you notice, the radius is 1. So if the radius is 1 on the bottom, that means the radius is 1 on the top. That means the cone's radius is the same as the cylinder's radius. Okay, and because we're combining both of these shapes, that means we're going to add them. So you're going to find the volume of the cylinder plus the volume of the cone, and that's your final answer. The tricky part is we look at the height. The height for this entire composite shape is 13 meters. And then the height for the cone is only 2 meters. So what is the height of the cylinder? Right, so you have to do a little bit of thinking to get the height for that cylinder. Okay, so at this point, I want you guys to pause the video and attempt to find the volume for both of these shapes to create the overall composite shape. Add them up when you're done. Okay, so go ahead and try this on your own. Pause the video, come back when you're done. Check your answers. Okay, so as you can see, I've separated into two equations. The cone is in green, and I got 2/3 pi for the cone. And then for the cylinder, I found out that the height of the cylinder was 11 meters because I had to take 13, which is the how tall the entire shape is, subtract the 2, which is how tall the cone is, and I got 11. So 11 is going to go into my height when I solve this. I get 11 pi for that cone. So if I'm going to add the two, I'm going to add 2/3 pi for the cone plus 11 pi for the cylinder, and I'm going to get 11 and 2/3 pi. But because this says to round your answer to the nearest hundredths, I'm going to actually multiply on a calculator 11 and 2/3 times pi, and I get 36.65 meters cubed, or cubic meters. Okay? All right, let's move on to the next example here. Oops. Bear with me 1 second. Okay. So we have a pencil now. All right, and we're going to find the volume of this pencil in millimeters. So if the radius of this pencil is 6 millimeters, the length of the shaft and the eraser is 200 millimeters. Okay, so that means this entire length of the shaft and the eraser, the whole thing is 200 millimeters. Okay, and the radius is 6 meters. And then the length of the actual tip of the pencil, which is where the part where you write at, is 15. Okay, so that length is 15. Go ahead and find the volume of this entire pencil and then leave it in terms of pi. Okay, so essentially you're finding the volume of a cone, and then you're finding the volume of a cylinder. Okay, so pause the video at this point and attempt this, come back and check your answers. Alright, so here we have the volume of the tip of the pencil. I'm using 15 millimeters for the height, and then 6 millimeters for the radius. I get 180 pi. Okay, and then for the cylinder, again, we're just using the cylinder formula. Same radius of 6, but then the length here is 200. So after solving that, I get 7,200 pi. And then I'm going to add them both up, because that's what we're doing. We're finding the volume of both shapes. We're going to add them up, and our final answer is 7,380 pi meters, or millimeters, excuse me, millimeters cubed. Okay? And it says to leave it in terms of pi. Okay, so that's why I'm not multiplying out and getting a decimal. That's my final answer. All right, let's move on to the next problem. Now we have a shape, a cube. Well, then there's a cone inside. So let's read this. It says a cube with a side length of 6 is partially drilled into leaving a conical hole with a diameter of 4 centimeters. Find the remaining volume of the cube after it has been drilled. So imagine, if you will, think of it like one of those handheld pencil sharpeners, the manual ones, and you've got to stick in your pencil to sharpen in this cube, right? So it's asking you, what is the volume of this shape after I take that cone out? So at this point, you're going to have to find the volume of the cube and the volume of the cone as well. And instead of adding, because we're not adding a cone on top of a cube, we're actually taking out the cone from the cube. So instead of adding, we're going to be subtracting. So at this point, I want you guys to attempt this problem on your own and come back and check the video when you're done. One more quick reminder, a cube, to find the volume of a cube, the special thing about a cube is that all sides are the same lengths, right? So to find the volume of a cube is just side times side times side, also known as side to the third power. Okay. All right, pause the video, come right back. All right, so here I have the volume of a cube. Again, it's side times side times side, and the side is 6 centimeters, so 6 times 6 times 6, I get 216. Then I find the volume of a cone, and because our diameter is 4, and how do you know it's the diameter? Is because it shows you the entire length across that circle. Okay, so that tells you that the diameter is 4. Well, if the diameter is 4, the radius is half of that, and that's how we get 2. So I popped in 2, and for the R, the height once again is 6, because the cone goes all the way to the bottom of the cube. So I solved everything, and I got 8 pi. So now, if I'm going to take away the cone from the cube, I'm actually going to subtract it. So the cube is 216 centimeters cubed, and then the cone is 8 pi centimeters cubed. And because the 216 doesn't have an 8 pi, you can't really subtract those. You'd have to convert 8 pi into a decimal. So technically 8 pi, let me change this right here. If I were to convert that into a decimal, it's 25.13, around there. Okay, and that's how we get the answer of 190.87 centimeters cubed. All right, let's move to the next problem. Now we've got an ice cream cone, a perfect ice cream cone. Think of it, I guess it's more like a snow cone than an ice cream cone, right? So the ice cream cone, or the snow cone, you see, is basically a cone with half of a sphere on top. That's only half of a sphere, right? So when you guys are solving this, again, ask yourself, are we going to add these two shapes, or are we going to subtract it? So you're thinking, well, you've got to take the cone, and then you're going to add that sphere. But are we adding an entire sphere or half a sphere? So half a sphere is what we call a hemisphere. And to find the formula of a hemisphere, it's easy. You just find the formula of a sphere, and then you cut it in half. Essentially, you divide it by 2. Okay, so I want you guys to attempt this problem, see what you guys come up with. Pause the video and come right back. All right, so we'll go ahead and look at the cone first, because that's the easier one to do. So the cone, I used a radius of 4, the height of 10, and I got a final answer of 160 over 3 times pi. Okay, we're just going to leave it in pi form for this problem. Then for the hemisphere, and notice I use the formula for the sphere, but then after that I'm going to divide by 2 because I only want half of that sphere. So I'm going to just go ahead and solve for the sphere first, and I get 256 over 3 times pi. Okay, notice to get that I had to use the height of 8 because there's radius plus radius will give me the height for a sphere. Okay, so once I've solved for that sphere, I'm now going to divide by 2. And to divide by 2, I get 128 over 3 pi. I take that volume of the hemisphere, which is in the green, combine it with the volume of a cone, which is in the red, and my final answer is right here. 288 over 3 pi. Okay, and of course, centimeters cubed. Okay, so that one's it's a fun one. You may see a problem like that on next week's or this week's quiz. All right, let's see what else we got here. All right, we have 3 identical cylindrical holes that are made through this brick. Okay, so you've got a brick here with 3 holes that are drilled straight through. And each hole has a radius of 1.4 centimeters. What is the volume of the brick? So in other words, what's the volume left over after I drilled out those 3 holes? So the volume of the brick is very similar to finding the volume of a cube, right? It's going to be length times width times height. So that's just a refresher. So the volume of the brick here is just a rectangular prism. It's not a cube, it's called a rectangular prism. So we're going to do length times width times height. Okay. Then if I want to remove those 3 cylindrical holes that I drilled, what is the remaining volume? Okay, so again, go ahead and pause the video and come back when you guys are done. Okay, so at this point I've found the volume of the brick, which is 21 times 8 times 9. That's pretty straightforward, and I get 1,512 centimeters cubed. And then now I'm going to find the volume of a cylinder. Notice, remember, we have 3 of these cylinders. So to find the volume of the cylinder, it tells me the radius is 1.4. And then our height, you got a bit tricky here. So the height is the height of the actual cylinder itself, right? The actual cylinder, the height, if it goes all the way through, is going to be 8 centimeters. So I'm going to plug that in for h, and then I get 15.68. So now, recall that we have 3 cylinders. So if there are 3 cylinders, then I've got to take 3 and multiply it by my volume of a cylinder, which is 15.68 pi. Right? So if I do 15.68 times 3, I'm going to get, and let me change this to green it back, that's 47.04 pi. Okay, so now what do I do with that information? Well, I've got the cube, or not the cube, the brick, and it's at 1512. I'm going to have to subtract it by 47.04 pi. So again, notice that the brick doesn't have pi in it because it has nothing cylindrical or nothing spherical or circular about it. So that's why there's no pi. So I'm going to that means when I subtract, right? Because I'm going to have to take away those 3 cylinders. When I subtract, I'm going to have to convert 47.04 pi. So on a calculator, I multiply 47.04 pi, and I get 147.78. Okay, I'm rounding there. So once again, because I'm taking away, I want to see what's left over. I'm just going to do on a calculator 512 minus 147.78, and I get, final answer is 1,364.21 centimeters cubed. Actually, 22 centimeters cubed. Okay. That is the remaining volume of that brick after we drilled out those 3 holes. All right, so that was a good challenging one. All right, so we're gonna go ahead and do our last one here today. And we have a cone that is inside a cylinder, right? So the question is asking, what will the volume be outside of the cone, but inside of the cylinder? So basically, what's the volume of that cylinder after I take out the cone? Okay, so you guys have enough information there to solve this. I want you guys to pause the video and attempt this. Come back when you're done. All right, so this one, it's pretty straightforward. Basically, I went ahead and solved the cone first. Doesn't matter which one you did. The cone got me a volume of 6 pi centimeters cubed. Then the cylinder, using a different radius and height, got me a volume of 96 pi centimeters cubed. So if I want to remove that cone and see what's left over in my cylinder, I have to start with a cylinder, which is 96 pi, and I subtract the cone, which is 6 pi. My final answer is 90 pi centimeters cubed, because it says to leave in terms of pi. Okay, so that's it for today, guys. To close this lesson, can you guys just write a brief sentence on how to find the volume of a composite shape? Okay, that's your closure activity. Just one sentence is good enough. And that's it. If you guys have any questions, you know how to reach me. Have a great day.